Hi everyone, welcome back. So the Trial Optima Inc. Myself Ali Sheikh. Today we are going to diving deep into the one of the most important standards in clinical data programming, the CDISC Analysis Dataset Model, or ADaM. Whether you're a biostatistician, clinical programmer, or data manager, this comprehensive guide will take you from absolute beginner to confident ADaM implementer. Okay, so this training is based on the ADaM model version 2.1 and implementation guidelines 1.1, focusing on the fundamental sections clinical data professional need to masters. Okay, so the training, so basically it required for regulatory submissions. So in this training agenda, we'll be going through the introduction of ADaM, fundamental principles and the basics, and also we'll be delivering some final thoughts. Okay, so introduction to ADaM. The analysis data model provides standardized structure for clinical trial analysis datasets that create transparent traceability from collection to results. Okay, so the ADaM stands for Analysis Data Model. It's a CDISC standard that provides standardized structures for clinical trial analysis datasets. Think of it as the bridge between your raw clinical data and your final statistical results. So here's the what is the ADaM does. So it just creates a transparent traceability from data collection to the final result, supports creations of analysis datasets and associated metadata, and also for the document data derivations and statistical analysis methods. So ADaM is a mandatory for regulatory submissions, a regulatory submission for clinical trial data. This isn't optional. Okay. So when you come to the why ADaM matters for the programmers. So ADaM is mandatory, so now why should you as a programmer care about ADaM? Let me give you like 4 compelling reasons. So ADaM datasets are designed to be one proc away from analysis results. This means no more complex data manipulations during statistical programming. Your datasets are ready to go. The second, standardized structures enable you to easily select appropriate data subsets, perform consistent statistical analysis across studies. Okay, less time debugging, more time analyzing. The third one, transparent communications. ADaM provides clear documentations how analysis results were derived. This facilitates communication with the sponsors and regulatory agency. Everyone speak having the same language. So ADaM datasets for the building blocks. ADaM data serve as a foundation for generating all analysis results presented in clinical study reports. Your figures, tables, listing all start here. Okay. So the clinical data flow. So let's look at where ADaM fits in the typical clinical data flow. So this includes the raw data collection. So this includes the electronic case report forms, lab data, patient report outcomes, all the messy real world data. And the step 2 will be the SDTM conversions. So we convert this to steady data tabulation model, a standardized structure of a collected data. And the ADaM derivations, the step 3, here's where we create analysis dataset with the parameters derived from SDTM according to your statistical analysis plan. Analysis, finally we produce tables listing figures for clinical study reports. Okay, so if you go to the next slide. So essential ADaM documentations. Okay, so before we dive into implementation, let's talk about essential documents you will need. So ADaM model is 2.1. This is your conceptual framework. So ADaM implementation guide version 1.1, your detailed instruction manual. ADaM structure for occurrence data structure version 1.0. ADaM structure for time to event analysis 1.0. FDA study data technical confirmation guide. So this is, think of this way, the implementation guide is your comprehensive manual that explains how to apply the conceptual framework outlined in the model document, model equal to 3 or implementation guideline practice. Fundamental principles. Now let's get into the meat of ADaM, the fundamental principles that govern everything we do. Okay, so the core ADaM principles, the principle 1, analysis ready. Datasets must be structured to support efficient generation of statistical results without further manipulation. Okay, no more spaghetti code. When you come to the principle 2, clear traceability, each derived value must maintain clear documentations of its source and derivation methods. Reviewers need to follow your breadcrumbs. Okay, so in the principle 3 is integrations, the metadata integrations, variable descriptions, control terminology, and derivation algorithms must be thoroughly documented. So everything has to be correct. So when you come to the principle 4, the standard compliance, adherence to the series naming conventions, structures, and control terminology is mandatory. No creative liberties here. Okay, so reference these principles come straight from the section 3.1 and ADaM model version 2.1. So the traceability in depth. So let's dive deeper into traceability. This is absolutely critical for regulatory acceptance. So metadata traceability. This establishes the clear relationship between the analysis variables and their source elements. The path look like this. So source SDTM, algorithm derivations, and analysis results. So the data point traceability, this identified exactly the predecessor records in the data lineage, raw data record, SDTM record, ADaM records. This is the path it goes. The traceability is mandatory for all ADaM datasets and is documented in the analysis data reviewer guide and define.xml. So here what this means in practice. So what reviewers must identify: source data elements used in derivations, algorithmic methods applied, imputation techniques for missing data, intermediate calculation steps. So what ADaM users should be able to do. So first of all, produce analysis results without additional programming, understand data derivation methods completely, trace any analysis value back to its source, execute statistical procedure directly on the datasets. So the metadata supporting traceability. So there are three key documents support traceability in your ADaM implementation. So first of all, the define.xml. This is your machine readable metadata document that describes the data structures, dataset structures and content, relationship within and between the datasets, variable definitions and control terminology, derivations, algorithms, and computational methods. So the next one, analysis data reviewer guide. I'm sorry, there is a small, the guide has the spell error. So this narrative documents explains the creation structure and uses of analysis datasets, context for analysis, standards approach, study specific implementation, decisions. So in the document, like this study data standardized number 3, study data standardized plan. This document planned implementation for data standards for the study, any planned deviation from standards, rationale for implementation choice. So ADaM data structures overview. So ADaM provides standardized structures for organizing analysis data. Let's look at the main types. So the three structure types appear: subject level analysis dataset, ADSL, one record per subjects. Okay, so contains demographic and baseline characteristics. So the three data structure, ADSL, BDS, occurrence data structures. So the ADaM employs standards, it has names, labels, values across all the data structures to ensure and the consistency across studies and submissions. So it has the clarity for regulatory views, interoperability between the systems, alignment with the CDISC standards. Each structures follow the specific implementation rules defined in implementation guidelines. Sorry. So the subject level analysis datasets, ADSL, one record per subject, contains demographic baseline characteristics, serve as a backbone for all other datasets. So in the basics data structure, BDS, multiple records per subject, one record. So next to BDS, let's look at BDS, the basics data structure. So this is your kind of workhorse for repeated measurements. So it has multiple records per subjects, one per parameters, or time point combination, perfect for lab tests, vital signs, questionnaires, and efficacy parameters. Analysis ready structures for statistical procedures. So it has the core variables: study ID, unit subject ID, copied from the ADSL. So param CD, param code, parameter code, parameter descriptions, and eval analysis value in the numeric format, and eval is the character analysis values. So the timing variable table, the timing variable, a visit, analysis visit, the numeric format of analysis visit, analysis date, imputation flag. So the derived variables, so you'll be having the change from baseline, percentage change from baseline value, endpoint indicators. So here the simple BDS data is showing how the parameters and answer value derived calculation work together. So the key implementation features will be the analysis of ready structures for statistical procedures. So built-in traceability to source data, standardized approach to baseline and change calculations, accommodates both observed and derived values. So BDS are particularly useful for analyzing the repeated measurements such as lab tests, vital signs. Okay. So occurrence data structures. The occurrence data structures are basically finally designed for specifically for time to event and data. So analysis the time to event data handles event that can occur multiple times per subjects. Support analysis of adverse events, concomitant medications, medical history, enables derivations of composite endpoints, facilitates identification of the first occurrence of events. So here how OCCDs work in practice: the screening, medical history documented, baseline, concomitant medication recorded, treatment, adverse event occur and are documented, follow-up, final safety assessments. Okay, so the reference for this call out from like ADaM occurrence version 1.1. So the types of understanding the ADaM variable types is crucial for proper implementations. So here the comprehensive introductions of analysis data model standards for statistical analysis in clinical trials. This presentation cover key naming conventions, variable types, and implementation guidelines essential for biostatisticians and clinical programmers. So the core variables, the types of ADaM variables, the core variables, standard variable required across all ADaM datasets that provide essential information for analysis and traceability. And analysis variables that directly support statistical analysis, typical prefixed with A like aval, avalc, and avisit. And the timing variables that captures temporal information, often using suffix like dt, tm, and dtm. And the flags indicators, so the Boolean variables yes or no that identify specific observations to indicate conditions relevant to analysis. Okay, so the naming conventions, ADaM naming conventions are strict but logical. Let's break them down. So the core principles follow ADaM IG if the variable concept matches what's presented. SDTM variables must be exact copies, name, label, and value. So ADaM standard variables required even if copying from SDTM. So the analysis variable related to aval and avalc, it has to be prefixed with A. So when you come to the variable pairs, one-to-one mapping, primary variable has no suffix. So the numeric aval is the primary character version is avalc. So the character TP is the primary numeric version is TRTPN. Okay. So when go to the standard general conventions for ADaM variables, so here N is the numeric version, C is the character versions. So the DTDM date, the date time, and FL means a flag. So ZRY ZY comes to the group and category, and DY will be the relative day. So the placeholder conventions, the W index digit 1 to 9, XX specific period 0 padded 01 to 099. The grouping are categorizations. So ZZ will be the index. So these are some general conventions. So next one, the reading and interpreting that ADaM IG. ADaM implementation guide is your best friend, but you need to know how to use it effectively. So so you should have to understand the source data identifications, so clearly document the source data, SDTM datasets, use it to derive new columns and rows, and the derivation algorithms implement well-defined replicable algorithms for all derived variables, ensuring the consistency across the data structures. And the traceability variables include variables that document derivation steps and enable tracking back to the source data points. So documentations maintain comprehensive documentation for all derivation process and analysis dataset specifications. Okay, so when the final thoughts and best practice. So let's wrap up with some final thoughts. So the ADaM implementation is not the rigid set of rules, but rather a framework for creating analysis datasets that are well documented, traceable, and fit for purpose. So the successful implementation required balancing standardization with the study specific needs while maintaining clear documentations and traceability throughout the analysis process. Okay. So the important considerations, you don't need to memorize the IG, use it as a reference. While ADaM is a common standard, that are multiple ways to organize metadata. Always refer to your study specific ADaM specifications. Focus on creating datasets that are well documented, traceable, and fit purpose. So, and yeah, that's it for this video. So the key takeaways, so ADaM is a mandatory for FDA submissions. Okay, so focus on traceability and documentations. So remember, analysis ready traceables are well documented. So if you found this comprehensive guide helpful, please give it the thumbs up, subscribe for more clinical data programming content to Trial Optima. Thank you so much for listening.